Tonight, something insane happened across the sky. 2 distant stars flared in violent deaths. The ground on Earth shook with sudden quakes, and out there in the dark, the interstellar visitor 3I Atlas ran into a twist almost no one saw coming. Different stories, scattered across space and time, yet they all arrived together, like thunderclaps rolling in from every direction at once. Before we go deeper, if you enjoy calm, science-based storytelling and don't want to miss the next chapter of this strange September, please tap like and subscribe. It helps more than you know, and it makes sure you can find your way back here whenever the night feels a little too big. Now breathe, because as dramatic as it sounds, all at once rarely means all connected. The universe is huge, and coincidences love big numbers. Still, the timing is wild, and the details are worth your attention, especially tonight. Let's start with 3I Atlas, the third confirmed interstellar object ever found passing through our solar system. Discovered on July 1st by NASA's Atlas survey in Chile, it isn't from here. Its path is open-ended, what astronomers call hyperbolic, so it will sweep in and then leave forever. As it warms near the sun, a thin envelope of dust and gas surrounds its core, making a ghostly glow. NASA notes it poses no danger to Earth. It will stay roughly 170 million miles away, at its nearest about 1.8 times the Earth-Sun distance. It will also pass the Sun at the end of October, a little inside Mars's orbit, roughly 1.4 times the Earth-Sun distance. To us, that means a safe, distant show. Interesting, beautiful, and very far away. So what's the unexpected twist? The Sun itself. Our star has been restless, tossing out bursts of charged particles called coronal mass ejections. Vast clouds that rush into space like invisible storms. When one of those gusts crosses a comet's path, it can whip the tail into a long streamer, brighten the coma for a while, or stir loose pockets of ice and dust. For 3I Atlas, some forecasts suggest a solar outflow may brush past it soon. That won't harm us and shouldn't harm the comet either. It simply turns the encounter into a live experiment, letting astronomers watch how an interstellar visitor responds to our sun's weather. Meanwhile, 2 stellar fireworks grabbed attention. First, a new nova was flagged in the southern constellation Centaurus, a sudden flash from a white dwarf star, stealing gas from its companion. Gas builds on the dwarf's surface until it ignites, and the system brightens dramatically. To human eyes, it can look like a new star has appeared. A nova is not a star's final breath. It's a flare-up, a reminder that even dead stars can surprise us when they feed. The second story is a true ending, the kind astronomers call a supernova. In one recent case, evidence points to a massive star that exploded under the influence of a nearby black hole companion, an unusual pathway to doom. Picture a dance where gravity is so lopsided that one partner begins to tear the other apart. When that star finally failed, it seeded space with heavy elements, the same kinds of atoms that later become planets, rocks, and living bodies. Supernovae are violent, but they are also generous. In the long run, they are how the universe recycles matter into new worlds. And then, Earth moved. On September 24th, a strong earthquake rattled Venezuela. 2 days earlier, a smaller quake woke people in California's Bay Area before dawn. These are human-scale events, close and loud. They are also normal geology at work, driven by the slow grind of tectonic plates, not by stars exploding a galaxy away or a comet cruising hundreds of millions of miles from us. It's natural to feel the rhythm of it, the sky erupting, the ground murmuring, the sense that everything is happening at once. Nights like this feed the imagination. They also tempt us to connect dots that don't belong together. So here is our compass for tonight. We will hold 2 ideas at once. First, the awe that comes when cosmic and earthly dramas share a headline. Second, the discipline to separate coincidence from cause. We will follow 3I Atlas on its safe, distant path, and talk about how a gust from the sun can reshape a comet's tail without changing its destiny. We will unpack the nova and the supernova, what they are, why they matter, and how they light the story of the universe from the inside out. And we will ground ourselves in simple, solid language so you can drift, listen, and still understand. If you are listening in the dark, let your shoulders drop. Let the numbers drift to the edges of your mind. You do not need equations tonight. You just need the picture. A traveler from another star skimming our sun's breath, a tired white dwarf flashing with borrowed fuel, a massive star far away giving back its elements to space, and our planet, doing what planets do, settling, shifting, sighing. We will take them one by one. And by the end of this episode, the chaos will look less like noise and more like a pattern you can hold in your hands. Ready? Let's step into the timeline and slow it down, piece by piece, until it makes sense. The timeline starts to breathe when we slow down and look at the traveler itself. 3I Atlas is a visitor on an open road. Its path is not a circle like a planet, and not a stretched oval like most comets that return. It is an open curve that bends around the sun and then keeps going. Think of it as a graceful sling. It will lean in, taste the sun's warmth, grow a faint veil of gas and dust, and then slip back into the deep. It belongs to the spaces between stars, and after this brief hello, it will go home to that quiet. What makes an interstellar object different from the comets we know is the story written in its motion. A local comet moves like a loyal companion. It comes back again and again, reshaped a little each pass. An interstellar object moves like a stranger crossing town at night. It is here once. Its speed and bend tell us it was set in motion far away, nudged by the gravity of other suns, maybe even kicked from a young star system where giant planets played a rough game of billiards. We have met visitors like this before. The first was a dark, elongated body that slipped by and refused to show a normal comet tail. The second was a true comet with a bright envelope and a clear streamer. From those two, we learned that interstellar space sends travelers in many outfits. 3I Atlas appears to be closer to the second kind, with ice that wakes up when sunlight touches it. That is good for us. Escaping gas carries dust. Dust reflects sunlight. Reflection makes it easier to track, to measure, to understand. Now bring in the sun, because the sun is not silent. Our star breathes out a constant wind. It is a thin flow of charged particles, but it spreads through all of space. On calm days, the flow is steady. On stormy days, the sun throws larger gusts that billow out like invisible surf. When that moving air meets the dust around a comet, it sculpts it. The tail points away from the sun not because the comet is speeding forward, but because the sun keeps blowing. If the wind grows stronger, the tail can stretch like a banner in a gale. Sometimes the wind gets so pushy it snaps a tail, and a new one grows. It is not damage in the way we think of harm. It is shaping. It is weather. This is why astronomers are excited tonight. 3I Atlas gives us a rare test. We have watched the sun play with local comets many times. Now we will see how an object built in another star's nursery behaves under the same breath. Is its dust fine or coarse? Does its gas carry common ingredients or unusual ones? Does its glow rise and fall in a familiar rhythm or in a new pattern? Each change in brightness is a clue. Each stretch and kink in the tail is a sentence in a language we are learning to read. You do not need specialist words to follow this. Imagine a snowball that has drifted for ages through a freezer. It holds layers of frost from different seasons, even from different climates. When you bring it into a warm room, it does not melt all at once. First a mist appears, then tiny streams begin to run. Some parts resist because they are packed tight. Some pop open because they hold trapped air. That is what sunlight and solar wind do to a comet. They wake different layers at different times. The result is a soft pulse of light that rises, falls, and sometimes flickers. What about safety? The simple truth is that distance is protection. 3I Atlas is far from us, and will remain far. Even a big change in its glow does not bring it any closer. Even a strong solar gust does not push it across the lanes of the planets. The lanes are wide. The traveler keeps to the shoulder. We can relax, watch, and learn. For those listening as you drift toward sleep, picture the scene in slow motion. A pale sphere of the Sunday. A thin, invisible wind flowing outward. A small, dark core with a soft halo around it, like a dandelion tuft in a breeze. The halo brightens a little, and the tail lengthens. It curves gently as the comet arcs around the Sunday. The camera of your mind follows at a steady pace. No sudden cuts, no noise, just the quiet grace of motion, the rhythm of light, the small changes that tell a bigger story. There is another reason this moment matters. When we study interstellar visitors, we are not only collecting facts about rocks and ice, we are sampling the building blocks of other neighborhoods in the galaxy. Our own system was once a place of chaos, with young planets growing, colliding, and clearing space. Some objects were thrown inward and became comets with regular routes. Some were thrown out entirely and became drifters. Those drifters now wander for ages until gravity guides them past a star like ours. When they pass, we get a taste of their home. It is like a message in a bottle, but the bottle is ice, and the message is written in the way it shines. In the next hours, we will link this soft, careful picture with the louder stories that grabbed headlines. The nova that flashed because a small dead star borrowed too much. The supernova that ended a giant's life and fed the future. The earthquakes that shook our own ground and reminded us that planets are not still. Each of these deserves its own clear frame and its own pace. None of them need to be tangled together to be amazing. If we keep them separate, we can see them more clearly. If we hold them together too tightly, we only grow anxious. For your comfort, remember this anchor. The sky is vast. Events that look like they happen together are often so far apart that their light left at different times in human history. The universe looks like a grand stage, but it is more like a city seen from above at night. Many lights turn on and off at once. They are not part of one plan. They are simply many lives, many cycles, many clocks. Our job is to notice patterns without forcing them and to enjoy the view. Settle your breathing. Let the image of 3I Atlas drifting under the sun's breath carry you. In the distance, the tail glows a little brighter, then softens. The traveler turns the corner and heads away. You are safe on your small blue world, watching. In a moment, we will turn to the first stellar flash and let its story unfold in gentle steps, from cause to glow to meaning. For now, float with the visitor and the wind. The first flash in our sky story is the quiet fire of a nova. Picture a pair of stars orbiting each other like skaters holding a long ribbon. One of them is a white dwarf, the small hot heart of a former Sunday. The other is a normal star that still has layers of gas to give. Over time, gravity pulls a trick. The white dwarf steals a little gas from its partner, not all at once, but as a slow drizzle that forms a thin whirlpool around it. Astronomers call that whirlpool a disk, but you can think of it as a bright scarf of falling vapor. This borrowed gas is mostly hydrogen, the simplest stuff in the universe. It piles up on the surface of the white dwarf like frost on a window. At first, nothing dramatic happens. The gas settles, the dwarf holds it tight, and the heat slowly climbs. White dwarfs are tiny compared to normal stars, yet their gravity is fierce. That pressure turns the thin layer into a hot shell. When the temperature crosses a critical point, the hydrogen ignites in a runaway way, not a gentle campfire, more like a flash from a camera bulb. The entire outer layer fuses for a brief time, and the system brightens so much that a star you could not see yesterday suddenly appears to the naked eye tonight. This is a nova. It is not the final breath of a star. The white dwarf survives. Only some of the built-up gas is blasted away. The light rises over days, then fades over weeks or months. In time, the slow drizzle begins again. Some pairs repeat this show every few decades, which is why you may hear the phrase recurrent nova. It is a cosmic heartbeat on a long scale. Why should we care about such a flare? There are two reasons. First, novae are laboratories for fusion on a surface. They let us test our models for how heat and pressure ignite hydrogen when there is no core to hold the flame. Second, they seed space with freshly cooked elements. Not as many heavy elements as a supernova, but enough to matter. The blast pushes dust and atoms back into the region around the pair. That material can later mix into the clouds that form new stars and planets. Now listen to the details your mind can hold without strain. When a nova begins, the brightness jumps by many steps of the scale astronomers use. On a star chart, the spot shoots upward. If you viewed it through a small telescope, you might also see its color shift. Early on, it can look very blue because the flash is hot. As the ejected gas expands and cools, the color warms a bit, and narrow lines appear in the spectrum. Those lines are the fingerprints of the atoms in the gas: hydrogen, helium, sometimes hints of nitrogen, oxygen, and other elements lifted from the dwarf's surface. Each line tells a part of the chemistry and the speed of the outflow. The shape of the light over time is called the light curve. Some novae fade quickly, some take their time. The fade tells us how much gas was blasted away, how dense it was, and how the cloud is shaped. A simple sphere would dim in one way. A cloud with clumps or jets dims in another. Modern observers use networks of small telescopes across the world to follow these changes night after night. Even with simple cameras, the timing of the rise and the fall can be measured by patient amateurs. That is one beauty of novae. They belong to everyone with a clear sky and a little curiosity. Let us stay with the white dwarf for a moment, because its nature matters. A white dwarf is the core of a star like our Sun after it has shed its outer layers. It is roughly the size of Earth but has a mass close to the Sunday. That makes its gravity astonishing. If you could scoop a spoonful of it, that spoon would weigh as much as a car. We cannot visit such a place, but we can infer its behavior from light and timing. The steady hum of the pair's orbit, the sudden flash of the surface fire, the narrow lines of the ejected gas racing away at thousands of kilometers per second. From these clues, we reconstruct the scene. Safety again. A nova in our galaxy may look bright, but it is far. Its light has crossed many years to reach us. The gas it throws off keeps to the small bubble around its system. There is no physical link between a nova far away and a quake on Earth. The scales do not match. The energy spreads over vast distances. By the time it washes over us, it is only light. And light is gentle. It can wake our sense of wonder, not our fault lines. If you are listening in bed, let the picture soften. 2 stars circle. The small one wears a halo of borrowed gas. The surface warms in slow motion, then a hush and a flash. The pair brightens as if a hidden lantern were turned toward us. In the days that follow, the light dims like a candle sheltered by cupped hands. Ash drifts into space. Silence returns. The dance continues. There is a quiet, humble lesson here. Not all bright events mean disaster. Some are the tidy release of built-up pressure. Some are the regular exhale of a system that has found a balance, even if that balance looks violent to us. In a way, a nova is a star pair clearing its throat, brief, loud, then calm again. In the next section, we will step from this repeatable flash to a true ending, the collapse and blast of a massive star. That story is heavier. It shapes galaxies. It forges the iron in your blood and the calcium in your bones. It turns a point of light into an expanding shell that can be seen across millions of light years. For now, hold the softer picture of the nova. Borrowed gas, sudden light, slow fade. A reminder that even in a restless universe, some fires are controlled, and some endings are only intermissions. The second flash is not a rehearsal. It is an ending that becomes a beginning. A supernova is the last act of a massive star, the kind that lived fast and burned through its fuel in only a few million years. Think of a star as an engine built from layers. In the outer rooms, hydrogen fuses into helium. Deeper in, helium turns into carbon and oxygen. As time goes on, the core stacks up heavier and heavier products. The layers feel like an onion drawn in fire. When the core reaches iron, the engine runs into a wall. Iron does not give back energy when it fuses. It only takes. The support vanishes in a breath. Gravity rushes in. The core collapses. That collapse is the snap you feel when a bridge cable breaks. In a heartbeat, the core falls and then rebounds. A shock wave forms and tries to punch outward through the star. Neutrinos, those ghost-like particles that almost never touch anything, pour out by the trillions upon trillions. For once, even they matter. Their flood helps lift the shock and drive it all the way to the surface. When the shock breaks free, the star explodes. For days to weeks, that one point of light can outshine an entire galaxy. It is a single voice that drowns out a billion others, and then it fades into a shell of glowing gas. There are several pathways to such a finale. One is the classic core collapse of a lone giant. Another is when a compact partner plays a leading part. A black hole or a neutron star can strip a massive companion, twist its shape and spur its fall. A third path looks quieter until the end. 2 white dwarfs in a tight orbit can merge. If the mass goes over a certain limit, a blaze ignites everywhere at once and the star is unbound. Astronomers label these paths with tidy names, but you do not need the labels to hear the music. Each path takes a heavy star to its limit and turns the inside out. Why should we care? Because this is where the universe forges the ingredients of life and land. The explosion makes and spreads elements far heavier than anything normal starlight can build. Calcium for bones, iron for blood and stone, nickel, cobalt, and more. Those atoms sail into the space between stars, cool, and join the next generation of clouds. From those clouds, new stars and planets form. In time, some planets grow oceans, some grow forests, some grow minds that can look back into the dark and ask where the atoms came from. The answer is that many of them were brewed in a single awful moment when a star fell and burst. A supernova also reshapes its neighborhood with a push we can imagine. The wave from the blast slams into nearby gas and dust. It compresses some parts and clears others. Compression can trigger new stars to light. Clearing can carve caves in the interstellar medium, where light travels more freely. Over millions of years, the scars of the explosion become structure. Filaments, bubbles, bright knots. When telescopes map a galaxy in detail, You can see the memory of these events traced across its arms like old riverbeds on a plain. If you could watch a supernova safely up close, the sequence would feel slow and fast at once. The core collapses in under a second. The light takes hours to reach the surface. The peak brightness arrives days later. The fade can take months to years as radioactive elements made in the blast release their energy. That slow fade turns into art. Astronomers draw a light curve the way musicians write a melody. Each supernova type plays a distinct tune. Some climb quickly and step down in clean slopes. Others wobble as if played through a chorus effect. From the shape of the tune, we learn the mass of the ejected shell, the makeup of its atoms, and the shape of the debris. There is a deeper quiet to this story. When the core collapses, it often leaves behind something new. If the mass is modest, a neutron star remains. It is a city-size object with more mass than the Sun, a place where matter is crushed into forms we cannot recreate on Earth. Some neutron stars spin like lighthouses and beam radio pulses. Others merge with partners long after, shaking space and ringing the universe with waves we can now hear. If the mass is larger, the remnant is a black hole, a horizon with no surface, a place where gravity closes the door. From an ending, a new mystery is born. Safety once more. A supernova bright enough to see with the naked eye can make headlines, but distance is our shield. These events usually occur far across our galaxy, or in others. Their light is brilliant. But light is gentle by the time it reaches us. The high-energy particles and pulses that could be dangerous fade with distance, like the warmth from a fire across a field. For an event to trouble Earth, it would have to be very close on the scale of stars. The night sky is full of drama, not threats. So why did the headlines stack on one night? Because the universe is a city after dark. In one window, a giant star reached its limit. In another, a white dwarf flashed with borrowed fuel. Outside, a traveler from another system lifted a shining tail in our sun's wind. Under our feet, tectonic plates creaked the way they have for ages. When you step back, the sense of chaos becomes a tapestry. Many clocks, each keeping its own time. If you are listening in bed, let the image soften again. Picture a vast black room. A single star blooms like a lantern. The glow spreads to a shell. The shell grows and thins. In its center, a small dark seed remains. Around it, dust cools and drifts. In a far future, that dust will help build a world. Maybe a blue one, maybe a red one. Maybe a place where someone stands at night and wonders about their own bright sky. In the next section, we will lower our gaze to Earth and talk about quakes. We will explain how rocks move, how stress builds, how a sudden slip sends waves through the ground. We will keep it simple, and we will keep it separate. No tangled threads, just clear pictures, calm steps, and the comfort that knowledge brings. The ground feels permanent until it moves. An earthquake is not the anger of the planet, it is a release. Picture Earth as a shell made of great rafts of rock that drift very slowly on a deeper, softer layer. These rafts are called plates. They push, pull, and slide past each other. For years, the edges can lock. Stress builds like a bent bow. Then one day a small patch lets go and slides. That sudden slip sends ripples through the rock. Those ripples are the quake. There are a few kinds of boundaries where plates meet. Some crash together. That can lift mountains and crumple rock like a rug pushed against a wall. Some pull apart. That lets hot material rise and create new crust on the seafloor. Some slide sideways. That is where we get long scars in the land called faults. The San Andreas in California is one of these. Any of these settings can host quakes. The details differ, but the core idea is the same. Stress gathers, friction holds, a patch breaks, energy moves out in waves. Those waves come in families. The first to arrive are primary waves. They push and pull like squeezing and stretching a spring. They travel fast and often feel like a sharp jolt. Next come secondary waves. They move the ground, side to side or up and down. They are slower and can feel like a rolling motion. Finally come surface waves that move along the skin of the planet. These can be the most damaging because they shake buildings from below with wide, slow motions. If you have felt a quake, you may remember that sharp start, then a sway, then a long rumble. That is the order of the waves. How strong is a quake? Scientists use a number called magnitude to tell how much energy was released at the source. Each step up in magnitude means much more energy, not a simple single step. A small increase can mean many times more power. People on the ground often describe intensity instead. That is how strong the shaking feels at a location. Intensity depends on distance from the source, on the depth, and on the kind of ground under your feet. Soft soils can wiggle more, making the motion feel stronger than on hard rock. Even for the same quake, you may hear about aftershocks. They are smaller slips that follow the main event as the fault adjusts to its new shape. They can arrive minutes later or days later. They fade in number and in strength with time. Sometimes a small quake comes before a larger one. That is called a foreshock, though you can only label it afterward, once you know a bigger slip was coming. These patterns are common in many places and are part of how faults settle down after a change. There is a gentle but important point here. The timing of quakes on Earth is not set by what happens in the sky. The push and pull along faults is controlled by plate motion and local stress in the crust, not by a distant star or a comet passing far away. Our planet keeps its own time. Headlines that line up in a short window do not mean the events share a cause. The night can be loud with sky news while the ground follows its steady, slow rules. How do we know where a quake began? Networks of sensors listen for the first waves. The exact arrival times at different stations let scientists draw circles from each one. Where the circles meet is the source, called the focus. The spot on the surface above that focus is called the epicenter. With only a handful of stations, you can already get a good fix. With hundreds, you can build a precise map, track the fault's shape, and even see how the rupture ran along it. Warning systems use the fact that primary waves travel faster than the strongest later waves. Sensors near the source detect the start and send an alert by wire or radio. People and devices farther away can get a brief head start. A few seconds can be enough to slow a train, open firehouse doors, pause surgery, or help someone step away from a high shelf. It is not prediction. It is rapid detection and quick notice. In some regions, that simple head start saves lives and reduces damage. What about buildings? The safest designs accept that the ground will move and give the structure ways to flex and absorb energy. Think of shock absorbers in a car, but for a tower. Base isolators can let the ground slide while the building above stays more still. Cross braces and careful framing spread the forces so no single part takes the full hit. Even small choices help. Securing water heaters, latching cabinet doors, fastening tall furniture to a wall. These reduce everyday hazards when the shaking begins. For listeners who are trying to relax, here is a calming frame. If you do not feel prepared, choose one tiny step, not 10. Fill a small bag with a flashlight, a bottle of water, and a copy of key contacts. Put sturdy shoes by your bed. Learn the simple phrase, drop, cover, and hold on. That means getting low, sheltering under a table or beside a bed, and holding on until the motion passes. Practice once in the daylight so the move is easy at night. Confidence grows from small actions. The deeper lesson mirrors what we saw in the sky. Energy builds in quiet ways. It releases in a bright moment or in a quick shake. Then the system settles, and the world goes on. None of this is personal. None of it is a sign from far away. It is the physics of plates and faults, the same slow dance that built mountains and open seas long before people named them. Hold the picture softly in your mind. A map with lines that mark old scars. Stress gathering like breath held in the chest. A brief release. Waves that pass and fade. Afterward, the land is the same in most ways, slightly changed in others, and life returns to its pace. The city lights come back on, the kettle boils, the moon rises. In our next steps, we will return to the visitor in the sky, to the nova's flash, and to the deeper blast of a supernova. Carrying with us this calm method, separate the stories, keep the scale in mind. Let awe be clean of fear. Tonight the universe is busy, but you are allowed to rest while it works. Method is the friend that calms wild nights. When the sky lights up and the ground rumbles, we can still breathe if we follow a few steady steps. Measure, compare, confirm, place the distance, hold the scale. Tonight we will use that rhythm to make sense of novae, supernovae, and the quiet traveler called 3I Atlas. Start with light. Every bright thing in space sends more than a point. It sends a chord of information. The total brightness is the volume. The color mix is the tone. Hidden inside is a pattern of thin lines that shift a little one way or the other. From those lines, astronomers read heat and motion the way a doctor reads a heartbeat. Lines nudging toward red mean the source is drifting away. Lines nudging toward blue mean it is moving closer. You can hold that idea without any equations. Picture a yardstick for light. That pattern tells us which way an object is moving and how fast. Now consider time. Telescopes do not only take single pictures, they also watch how light rises and falls over days. That change with time is a signature too. A nova often climbs quickly and fades over weeks or months. A supernova can blaze much brighter and then step down in a smooth, long glide. Dusty comets make softer patterns as sunlight wakes different layers, and the wind from the sun pulls a tail into shape. When scientists say the light curve matches a known type, they mean the tune fits a song we already know. Distance is how we turn brightness into scale. Nearby distances can be measured by geometry, much like the way your two eyes give you depth. Very far distances often come from standard lamps, events whose true brightness is known from long study. Some kinds of supernovae are regular enough to serve as mile markers for the universe. If you know what a lamp should look like up close, and you see how bright it looks from here, you can tell how far it must be. That simple idea keeps fear in check. A blast across town is not the same as one across a galaxy. What about the traveler? With 3i Atlas, teams measured position and speed again and again to draw a smooth path through the sky. The curve is open, not closed. It bends around the sun and then keeps going. That bend and that speed tell us it came from beyond our system and will not return. Its closest pass to Earth is still very far, so this is a distant show. Small telescopes and patient watching are enough for many observers. Large facilities add sensitive cameras to pull detail from faint light. Radio dishes listen for faint whispers when gas interacts with sunlight or with the solar wind. Teams matter. A single observatory can miss a change because clouds roll in or the sun rises. A network across the world can keep watch without gaps. Volunteers with backyard setups send in brightness notes, night after night. Their steady measures fill the lines between the louder chords of major telescopes. Science is a choir, not a solo. The song is strongest when many voices sing. Light travel time removes the urge to force connections. A nova in a far arm of our galaxy is a message that left years ago. A supernova in a nearby galaxy is a story that began long before our modern cities were built. The universe is a library where each shelf holds books written at different times. If two books arrive on your doorstep together, it does not mean the plots are linked. It just means the delivery van came once. Here are a few calm truths in plain words. A comet that brightens is not falling onto us. A tail that grows is not a spear. It is dust and gas pushed away from the Sunday. A nova that flares is not a sign of a quake under our feet. The ground answers to plates and faults, not to light from a distant star. A supernova in a remote galaxy is a grand lantern for our eyes and instruments, not a threat to our air or seas. Distance and dilution are guards that work quietly and well. People also ask about cycles and omens when several events make the news at once. The human mind loves patterns. That love is a strength when we let it guide careful study. It becomes a trap when we tie unrelated events with a rope of fear. A better rope is scale. Put the sky on one table and the ground on another. Let each story stand in its true size. Then you can admire both without mixing their shadows. If you want a picture simple enough to carry into sleep, imagine a park at dusk. Fireflies blink in the hedges. A lighthouse beam sweeps the far edge of the water. A lone traveler walks a path, a scarf lifting in the breeze. Beyond the hill, a cart rattles on a road. These moments are not one event. They are a scene. You are safe on the bench, watching. You can look at each light in turn. You can let the sounds overlap without making a storm in your mind. As this episode continues, we will keep returning to method. Measure the light. Compare the signature. Check with friends. Place the distance. Hold the scale. With those steps, wild nights turn understandable. Awe does not fade. It settles into something better. A clear, steady wonder that lets your shoulders drop and your eyes close while the universe keeps working on its patient time. Wonder grows when we learn how to look. Tonight we will learn to look in a way that is calm, simple, and faithful to what the sky is telling us. Think of it as a nighttime craft. You do not need big equipment. You need patience, a gentle map in your mind, and a few easy habits that make the darkness friend instead of stranger. Begin with your own breath. Slow it. Let your shoulders drop. Now picture where everything sits. The sun is behind the night side of Earth. Its thin wind is still moving outward, shaping the tails of comets and the glow of their halos. Far beyond, a nova has flared like a match and begun to dim. Farther still, a supernova has become a lantern that will fade over months while its shell expands. In our own solar neighborhood, The traveler we call 3I Atlas is carving an open curve around the Sunday. It glows a little as sunlight warms its skin and coaxes gas from hidden ice. That gas carries dust, and the dust reflects light. The whole scene is quiet from where we sit. If you want to watch, give your eyes time. Dark adaptation takes many minutes. Put your phone away or use its dimmest red setting. Step outside and let the night fill in. You will be surprised how much more you see after a short wait. Binoculars make a bigger jump than most people expect. A small pair can pull a faint mist from the background and turn a guess into a certainty. A simple star chart helps you point the glass. Note one bright landmark, then step to the next. You do not need to memorize coordinates. You only need to walk the sky the way you would walk a familiar street. The traveler's tale tells its own small story. It points away from the sun, not along the path of motion. That one fact clears up many worries. The tale is not a spear aimed at anything. It is a banner blown by the star we live with every day. As 3I Atlas turns the corner around the sun, the tail will swing like a windsock. Sometimes it will look longer, sometimes shorter. A sudden change can mean the solar wind grew more lively, or a pocket of gas burst from the surface. None of this alters the safe distance. It is weather, not fate. If you enjoy keeping a little log, write down 3 things when you look. First, what the sky itself is like. Clear, hazy, moon bright. Second, what you used to look. Eyes, binoculars, a small scope. Third, what you think you saw. A faint smudge near a certain star, a slim tail through the field, a brightness that seems a bit more than last week. These notes seem small, but they train your mind to compare gently instead of dramatizing in the moment. They also let you enjoy the tiny sense of growth that comes when a smudge becomes a familiar friend. Now bring your thoughts back to those 2 stellar fireworks. A nova is a surface flash on a tiny, dense star that is borrowing gas. It is a flare-up of stored fuel, a brief blaze, then a soft fade. A supernova is a deeper ending, a core that collapses and drives a shell outward with enough force to outshine a galaxy for a while. Both are far, both are safe to witness, and both are gifts for our understanding. The first teaches us how thin layers ignite. The second shows us where the heavy atoms in our bodies were made. It is human to connect tracks. When the sky flashes and the ground shakes in the same week, the heart wants a single cause. But the world is written in many hands at once. Plate edges slip because rock is rough. Stars burn and fail because physics sets limits to how they can hold themselves up. Comets grow bright because sunlight warms ice. These are different books in the same library. The stories can sit side by side without sharing a plot. If you feel uneasy, let scales speak the way a kind teacher would. Light from a distant explosion is breathtaking, but by the time it reaches us, it is only light. It warms nothing. It moves nothing. It harms nothing. A comet tail can stretch for miles upon miles, but it is so thin that you could pass through it without noticing. An earthquake that rattles a city is strong nearby and fades with distance, like the ripples from a stone tossed in a pond. Scale is the map that keeps worry small. There is also joy in listening together. Amateur observers all over the world share notes from small telescopes and cameras. Their work is humble and powerful. It fills the gaps between larger observatories and extends the timeline. When a nova flares, these watchers catch the first rise. When a supernova brightens, they trace its steps night after night. When 3I Atlas swells or softens, they mark the changes. Science becomes a chorus. The melody is clearer when many voices sing. Let us end this lesson with a simple picture you can carry to bed. Imagine a still lake at night. Fireflies blink near the shore. A bright lighthouse sweeps a beam over the water now and then. Out on the lake, a small boat drifts past, a scarf of mist trailing behind. In the hills beyond, a cart creaks on a road and is gone. Each light is its own thing. Each sound is its own thread. You are on the dock with a blanket around your shoulders. You can watch as long as you like. You can close your eyes and still see it. The path forward in this episode will keep the same tone. Soft steps, clear ideas. We will return to the traveler and spend time with what makes an interstellar object different from a local comet. We will look at how dust grains tell us about the nursery where 3I Atlas was formed. We will visit the nova again with a closer ear for the elements in its light. We will listen to the long song of a supernova as its shell cools and as its remnant grows into a new puzzle. Each piece will have a clean border. Each idea will be free of hurry. For now, let your breath fall into a slow tide. Know that the sky is working on scales too large to rush you. Know that the ground under you keeps its own schedule that has nothing to do with far lights. You are safe to wonder. You are safe to sleep. Interstellar objects carry a different kind of memory. Local comets are the leftovers of our own family kitchen. Interstellar travelers are crumbs from someone else's table. To understand a visitor like 3I Atlas, think about dust grains as tiny time capsules. A grain can trap clues about the temperature where it formed, the kinds of light that baked it, and the chemistry that settled onto it as frost. When sunlight warms the surface, those grains drift free in the coma and tail. By studying how the tail reflects light and how the glow changes from night to night, astronomers read a quiet diary from a nursery we will never see directly. There are two main tails to imagine. One is the dust tail, made of small solid bits pushed gently by sunlight. It looks soft and curved, like smoke drawn out by a breeze. The other is the ion tail, made of gas that lost electrons and now obeys magnetic fields carried by the solar wind. That tail is straighter and points more exactly away from the sunday. Sometimes a comet shows both at once. A broad brush of dust with a narrow needle of ionized gas running through it. When the solar wind kicks, the ion tail can snap and reform like a ribbon in a gust. Observers call that a disconnection event. It is not the core breaking. It is the tail reacting to weather in space. Color is a clue wrapped in beauty. Dust tails can look a touch yellow or gray because they scatter sunlight much the way fog does. Ion tails can glow a subtle blue because of molecules in the gas that shine when charged and then calmed by the sun's light and wind. Cameras collect that light and split it into its fine lines, which tell which molecules are present. Water broken into fragments, carbon compounds. In some comets, even a faint trace of sodium can paint a delicate third tail if conditions are right. Each piece adds a brushstroke to the portrait of the material inside. Now, why would 3I Atlas carry a different mix than our local comets? The answer lives in the star systems where these objects were born. In young planetary nurseries, giant planets throw their weight around. They scatter smaller bodies inward and outward. Some get parked on long ovals and return like clockwork. Others are tossed clear and become drifters between stars. If the nursery was hotter or colder, if its star was brighter or dimmer in certain colors, if nearby stars bathed it in more radiation, the ices and dust that formed will not match ours exactly. When we watch how 3I Atlas wakes under sunlight, we test those differences against our expectations. Think about how waking works. In slow steps, a dark crust may cover fresh ice beneath. Sunlight warms the crust. Tiny holes open and let gas leak out. Gas carries dust, and the coma grows. As the visitor turns around the sun, sunlight reaches new pockets and old vents cool down. The pattern of brightening and fading becomes a map of those hidden layers. If the dust grains are large, the tail glows steadily and curves wide. If the grains are fine, the tail thins and stretches far. If certain gases are abundant, particular spectral lines strengthen. No single measure tells the whole story, but together they form a gentle truth. Orbit shape is a separate signature that sits beside chemistry. A local comet is tied to the sun by gravity and will return. An interstellar object has more speed than the sun can hold, so the path bends but does not close. That extra speed is like a stamp on a passport. It tells us the traveler began somewhere else and will not linger. For 3I Atlas, the hyperbolic path is that stamp. The open curve is our proof that we are watching a one-time hello. Even without equations, you can feel why speed and distance keep us safe. Space is wide. Planets have broad lanes, and small travelers keep to the edges unless a strong push brings them near. The sun and the planets do tug on 3I Atlas, but those tugs only bend the path into its graceful swing. They do not aim it at Earth. We are watching a parade from a hill, not standing in the street. There is a quiet art to catching the smallest changes. Large observatories pull sharp spectra. Small telescopes collect brightness night after night. Some teams compare the light from the coma center to the light in a thin ring just outside it. If the center brightens while the ring lags, a fresh jet has turned on. If the ring brightens first, dust is drifting outward and spreading. A calm, patient habit of measuring is the secret here. The story unfolds in hours and days, not in sudden jumps. All of this helps answer a simple human question. What is it like out there? Not in poems, but in materials. Are other nurseries rich in the same carbon frost that coats our comets? Do their grains clump the way ours do? Do their ices hide pockets that burst and flare in short breaths? When an interstellar visitor answers yes or no, it shrinks a little of the distance between stars. We cannot go yet, but a sample comes to us, written in light. Hold an image as you drift toward sleep. A small dark seed moves through a sunlit room made of space. A mist breathes from tiny pores. A broad, pale brush of dust curves behind, and a thin blue needle points straight away from the sunday. Now and then a curl in the needle snaps and slips downstream, then rebuilds, neat as a ribbon in wind. Nothing crashes, nothing hurries. It is slow craft at a bright distance. It is a message you can read without fear. In our next section, we will follow that message deeper into chemistry. We will speak softly about what those fine spectral lines mean in plain words. We will also return to the nova and the supernova to hear what their lines say about temperature, speed, and the gifts they pass to the future. Calm steps, clear pictures, and steady wonder will guide us. Light is more than brightness. It is a language. When a comet glows, when a nova flares, when a supernova turns night into a lantern, each one writes a message into its light. We can read that message by splitting the glow into its colors and then into thin, bright lines. Those lines are the footprints of atoms and molecules. Each element leaves a mark at a specific place. Hydrogen leaves one pattern, sodium another, carbon compounds a different set. You do not need the names to follow the idea. Think of a piano. Each key makes its own note. A chord is many notes together. A spectrum is a chord played by the sky. Begin with the traveler, the interstellar visitor we call 3I Atlas. Around its small dark core is a thin cloud called the coma. Sunlight touches the ice and a gentle fog lifts. Inside that fog, simple molecules appear. Water separates into parts. Carbon-bearing gases wake and shine. Through a small telescope with a sensitive camera, those gases paint narrow lines in the blue and green. Dust grains reflect sunlight more broadly and give a soft gray wash to the spectrum. The mix of lines and wash tells us which ices are waking and how fast dust is flowing out. Temperature is folded into the width and strength of those lines. Warmer gas moves faster, and that motion blurs the lines a little. A stronger outflow can make a line brighter. If a new vent opens on the surface, a line may grow for a few hours and then settle. When the solar wind grows gusty, the ion tail stiffens and certain charged molecules brighten more than before. These changes are small and calm. They do not change the path. They simply let us listen to the surface as it breathes. Now turn to the nova. A white dwarf steals gas from a partner star and piles it on its skin. When the layer ignites, the system brightens and the spectrum blossoms with sharp lines. Early on, hydrogen lines can be very strong. As the gas shell expands and cools, other lines appear: helium, oxygen, nitrogen. Their pattern shifts with time. The lines also split or tilt, not because the elements change, but because parts of the gas shell are moving toward us or away from us. Motion toward us nudges a line slightly toward blue. Motion away nudges it toward red. The spread tells how fast the shell is flying. The tilt hints that the shell is not a perfect sphere. Perhaps it is a ring with a puff on each side. Perhaps it is full of clumps and knots. The light is a map drawn in music. A supernova writes a louder score. Right after the blast, the spectrum can look smooth and hot, like a bright continuum with only a few shallow features. As days pass, heavy elements made in the furnace show their marks: calcium, iron, nickel, cobalt. Their lines are wider because the debris is racing outward at thousands of kilometers per second. The light curve, the rise and fall of brightness with time, partners with the lines to tell the story. Some supernovae rise quickly and fade in a way that matches the slow decay of unstable elements inside. Others show a plateau, a long shoulder in the light curve that means a thick envelope is cooling and recombining while it expands. The shapes are different melodies, each tied to the engine that drove the blast. These readings are simple in spirit, even when the instruments are refined. We shine starlight through a prism or a grating. We measure where the bright lines fall. We note how strong they are and how wide. We watch them change, night after night. Then we compare to patterns that have been studied for decades. That comparison is the heartbeat of calm science. It keeps us from jumping to wild links. It lets us say with quiet confidence that a nova is a surface flash, a supernova is a core collapse or a whole star burn, and a comet is a sun-warmed breath. Spectra also connect to touchable things. Sodium lines in a comet tell us that even a faint sprinkle of metal atoms can glow in the right light. Carbon-bearing lines tell us that the building blocks of organic chemistry are common in frozen clouds. In novae, certain lines reveal fresh elements lifted from the white dwarf itself. In supernovae, iron and nickel lines tell us that the atoms in your blood and in the rock under your feet were forged in ancient fires, not unlike the one we are watching now in the distance. That is not poetry. It is a straight line from measurement to meaning. Distance returns as a friend. When we see a supernova in a nearby galaxy, we can use the pattern of its light to judge its true brightness. From that, we estimate how far the galaxy is. Many such measures across the sky help us map the size and shape of the universe. When we see a nova in our own galaxy, we can place it in a spiral arm and learn about the kinds of stars that live there. When we watch the lines from 3I Atlas, we learn how an object from another star's nursery behaves in our sun's light. Each reading adds a stitch to a vast quilt. You can carry this without any math. Imagine that every light in the night has a voice. A prism lets you hear the separate notes. Some voices sing hydrogen, some sing metals made in deep heat, some sing dust, soft and gray. Over time, the song changes as gas cools and spreads. By listening with patience, we hear a story we can trust. If you are drifting toward sleep, hold a small picture. A dark room, a beam of starlight passing through a thin crystal. On the wall, a band of colors appears, crossed by fine bright threads. Someone marks the threads with a pencil, night after night, gently, without hurry. In those marks are temperatures, speeds, and names of elements. In those marks is the cool comfort that the universe can be understood, bit by bit, without drama. In the next section, we will return to the traveler's origin story and ask what its dust and ices hint about the star it once orbited. We will also revisit the nova and supernova with the same soft tools and see how their light guides the birth of new stars in the long run. Calm steps, clear lines, and simple words will lead us on. Origins leave fingerprints in ice and dust. To guess where 3I Atlas began, we follow those prints the way a tracker follows soft marks in sand. Young star systems grow inside wide, flat clouds of gas and dust called disks. Heat from the star falls with distance, like a campfire whose warmth fades as you walk away. Different ices can only survive beyond certain rings where it is cool enough. Water can freeze a bit closer to the star. Carbon dioxide and carbon monoxide need colder rings farther out. Dust grains collect frost that matches the ring they lived in. When a small body forms there and is later thrown out into space, it carries that frozen record with it for ages. As sunlight wakes 3I Atlas, that record breathes. If water products brighten first, it hints that the visitor formed in a region where water ice was common. If carbon-bearing gases show up strong and early, it suggests a colder birth farther from its old Sunday. The balance between very fine dust and larger grains adds more hints. Fine dust points to gentle growth in a quiet zone. Coarser grains can point to a place where grains clumped and stuck together often, perhaps helped by slow turbulence in the disk. None of these clues alone tell a full story. Together they sketch a portrait of a nursery we cannot see. Grain structure matters too. Some grains are simple, like tiny glass beads. Others are layered, with hard cores wrapped in softer shells. When sunlight warms a layered grain, the outer frost leaves first, then deeper ices follow with a small delay. Those delays can create a soft rhythm in the light of the coma. A slow beat day by day may mean stacked ices and a crust with pores that open and close. This is the kind of calm detail that small telescopes can watch, as well as large ones. Many notes over many nights reveal the heartbeat of a surface that has slept for a long time. How does a body lose its home in the first place? Giant planets are the usual suspects. In young systems, they sling smaller objects around with casual power. A close pass can pump speed into a small traveler and toss it clear of the star's hold. Over millions of years, the galaxy fills with these drifters. Most wander in darkness forever. A few pass near other stars and take a brief turn through those neighborhoods. This is how a small relic from a far place can cross our sky. It is not rare on the scale of the galaxy. It is only rare for a single human lifetime. When a visitor like this meets our sun, we get a free sample return written in light. The sample is not a chunk in a lab. It is a pattern of brightness and color and lines that mark which molecules glow. Even so, the meaning can be plain. If the same building blocks show up again and again, it tells us that planet making uses similar stock across many nurseries. If we find odd mixes, it says the menu varies with local heat and light. Either way, We learn how common our kind of chemistry may be. Now draw the circle wider. The nova we met earlier adds a steady sprinkle of fresh atoms to its region. The supernova adds a storm of heavy elements to its region. Over time, those gifts mix into big clouds. When shock waves from earlier bursts travel through those clouds, they squeeze some parts and help new stars ignite. In this long cycle, fire makes dust and gas richer. Gravity gathers that mix. New stars form with planets around them. Some of those planets may hold oceans and air. Some may hold life. Some will break apart. Some will throw out small bodies by the millions. Long after, one of those bodies may drift past a different sun and paint a faint tale for strangers to see. We can hold this whole loop in simple pictures. You do not need special words. Think of a forest after a storm. Branches fall and rot. Their matter returns to the soil. New shoots take that food and rise. In time, birds carry seeds to new clearings. The forest changes but stays a forest. In the galaxy, stars live and die. Their remains feed clouds. Clouds form new stars and worlds. Small pieces travel far and tell their story where they pass. 3. Atlas is one such piece carrying a leaf of history from a far wood. A question often comes next. Could the heavy elements from supernovae be too rare for life to be common? The answer is that galaxies are good at recycling. A single grand blast spreads enough iron, calcium, and other metals to seed vast regions. Billions of years of cycles build up the mix. The night sky looks empty, but the long arithmetic of time is generous. Our bones and blood are proof that it works. Another gentle worry asks if such blasts endanger life at a distance. Distance is the shield. A supernova must be extremely close on the scale of stars to trouble a living world. Most are very far. Their light is brilliant, but light alone is kind by the time it reaches us. It helps us measure. It does not burn. It lets us look back and see the steps that built the materials we use every day. Bring your thoughts back to the traveler. Imagine its past, a cold ring beyond a young star where grains dance in slow currents. Frost grows on dust, pebbles clump, a small body forms. A giant planet passes and with one careless tug sends it away forever. Ages pass in silence. Then the visitor meets our Sunday. A thin fog rises, a tail glows. For a few months a stranger becomes a teacher. Then darkness again, with the lesson left in our notes and in your memory as a simple, quiet scene. In the next section we will follow those notes into the birthplaces of stars themselves. We will ask how the glow of a nova or the shock of a supernova can nudge a cold cloud into starting new suns. We will keep the language soft and the pace even. You will not need equations. You will need only the patience you already carry. The same patience the universe uses to turn dust into worlds. Star birth begins in the quietest places. Picture a giant cloud of cold gas mixed with thin dust grains drifting between the stars. From far away, the cloud looks dark because it blocks background starlight. Inside, the temperature is only a few degrees above absolute zero. At that chill, atoms move slowly, and the dust works like a blanket. Gravity waits. It nudges wherever the cloud is, a little denser. Over long years, those denser patches gather more mass, and the nudge grows into a pull. The pull becomes a slow inward slide. A push from outside can help that first step. The thin shell from a nova can sweep across a cloud like a breeze across tall grass. A supernova sends a stronger front, a true gust that compresses a region into a tighter knot. The push does not need to last long. What matters is the squeeze that tips a patch over the line, making its own gravity grow faster than pressure can resist. Once that happens, collapse begins in earnest. The falling patch splits into smaller knots. Many newborn stars can form in one cradle. As a knot shrinks, its center warms. Dust and gas swirl into a flat disk around the young star, the way water makes a whirlpool as it drains. In that disk, pebbles collide and stick. Over time, some become the cores of planets. Others remain as belts of rubble and ice. The young star flickers as matter rains onto it in short bursts. Jets of hot gas shoot from its poles. Around it, the rest of the cloud glows softly as dust re-radiates the heat it absorbs. To a telescope tuned to infrared light, these nurseries look like warm cocoons, dotted with tiny seeds of fire. Now link this newborn scene back to our three stories. The nova is a modest gardener. Its wind loosens and lifts, adds a sprinkle of freshly made atoms, and moves on. The supernova is a deep plow. It tears a cavity, piles a rim of compressed gas, and sows the heaviest seeds the galaxy can make. In that rim, new clusters often appear in arcs and rings. With time, their own light and wind carve pillars and caverns from the surrounding cloud. The cycle continues, shaped by push and pull, squeeze and lift. Comets, both local and interstellar, are small diaries written during this early stage. They collect in the cold outer rings of young disks and keep the chemistry of their birthplace on ice. When we read the light from a traveler like 3I Atlas, we are peeking into those first chapters. If its dust is rich in certain carbon compounds, it hints at a cool, shaded ring in its original disk. If some gases appear late, it suggests deeper stores that only wake with stronger sunlight. In that sense, each change in its glow is a memory unfolding. Starbirth also explains why the sky can feel crowded in headlines yet empty to the eye. These clouds are vast, but their changes are slow. A supernova seems sudden because we see the finish, not the long struggle inside. A nova flares quickly because its fuel sits on a surface. A comet brightens because the sun warms shallow layers. Clouds, by contrast, move on the clock of patience. They can take millions of years to turn from dark lumps into bright clusters. When the stories stack in a single week, remember that you are hearing notes from very different bars of the same long song. Safety threads through this picture too. The same distance that keeps a supernova's harshest breath from us also keeps the collapse of far clouds from touching daily life. We are observers. We listen to light and learn. The forces that shape star nurseries are gentle at our remove. They leave only beauty for the eyes and calm for the mind. If you would like an image to rest with, try this. You are standing at the edge of a quiet field before dawn. Fog lies close to the ground. From beyond a ridge, a soft wind arrives and makes ripples in the fog. In the hollow of the field, the fog thickens, then slowly settles into a pool, darker than the rest. Fireflies blink over the pool. One by one, tiny glows appear within, each a seed of light. Some grow, some fade. A far lantern flashes once on the hill, then is gone. Somewhere, a cart rolls past. The scene is gentle. The shapes change without hurry. This is how starfields begin. Bring the thought back to the traveler. The same jets and bursts that young stars throw from their poles shape the dust around them. That dust is the raw material for pebbles, rocks, and icy bodies. If a young system grows a giant planet early, its gravity can fling many small bodies outward. Some are parked in distant belts and return on long loops. Some are cast into the deep between stars. Ages later, one crosses our sky and earns a brief name. Its true name is its history. It carries the flavor of its first cloud, the heat of its first sun, and the scars of the shove that sent it wandering. There is one more comfort hidden in this story. The galaxy is good at recycling. Novae and supernovae enrich the raw gas. Gravity gathers the mix. New stars and worlds appear. Small pieces travel far and tell their story where they pass. When we say that iron in your blood and calcium in your bones were forged in ancient fires, we mean it in the plainest sense. Those atoms were made, scattered, cooled, and folded into the cloud that became our sun and earth. You are part of the cycle. You are evidence that the long arithmetic of time is generous. If you are drifting toward sleep, hold one last picture. A dark nursery cloud floats in space like a quiet bay at night. Along its rim, a wave from a long-ago blast rolls in and presses the waterline. The bay dimples. Small eddies form and spin into shallow whirls. In each whirl, a point of fire kindles. Far away, a lone traveler passes with a pale veil and a slim tail, a postcard from another bay. Nothing crashes. Nothing demands. The universe works on a patient schedule, and you are allowed to rest while it does. In the next section, we will return to human scale and ask what these grand cycles mean for our daily lives. We will talk about clear habits that keep curiosity strong and fear small when news runs hot. We will set simple expectations for the traveler's path in the weeks ahead, and for what calm watchers might see with eyes and small glass. No hurry. Clear steps. Gentle voice. A steady light to read by. Calm habits shrink fear and grow clarity. When headlines stack and language gets loud, simple routines bring the sky back to size. You do not need equations to stay steady. You need a small plan you can keep. Begin with what you control. Sleep well, breathe slow, and choose when to check the news. A quick look once or twice a day is enough. The universe moves on long clocks. Urgent words do not make distant events closer. If a story matters tomorrow, it will still matter tonight after you rest. Build a tiny observing kit. A notebook and a pencil. A simple star chart app set to a dim red mode. Binoculars if you have them. A warm layer and a hat. Place everything by the door so a clear evening is easy to accept. Friction is the real enemy of curiosity. When the kit is ready, the sky is closer. Use 3 gentle questions for any space story. What is it? How far is it? What changes for me? A comet brightening is a sun-warmed breath. A nova is a surface flash on a dense remnant. A supernova is a deep collapse that throws heavy elements into space. All are far. None change your day. The answer to that third question is almost always nothing practical beyond wonder. That is enough. For 3I Atlas, set soft expectations. It is on a one-time path around the sun, an open curve that will carry it away for good. It may grow a little brighter as sunlight wakes new pockets of ice. It may show a dust tail like a pale brush and an ion tail like a slim needle. On some nights it may seem steadier. On others it may waver as the solar wind breathes. Do not chase dramatic jumps. Let the slow rhythm be the point. Watching can be as simple as a 5-minute ritual. Step outside. Let your eyes dark adapt. Note one bright landmark, then step across the sky with your chart. If you see a faint smudge near where the chart says the traveler should be, pause and enjoy the calm surprise of recognition. If you do not, that is fine. Clouds and moonlight and city glow are part of life. Write a single line in your notebook and try again another night. Curiosity is not a test. It is a friendship. If you want a slightly deeper look, try this easy habit. When you think you see the coma, shift your gaze a little to the side. Your eye is more sensitive off-center in low light. The smudge may pop out and then fade. That is normal. If you use binoculars, brace your elbows or lean against a wall. A steady view reveals more than expensive glass. Keep numbers soft. If someone quotes distances, let the key idea carry you. Hundreds of millions of miles means safe. A few times the Earth-Sun distance means very far. If someone quotes speeds, remember that speed alone does not point an object at us. Paths are set by gravity, and this path bends wide around our lane. Knowing that is enough to relax your shoulders. Make a home for awe, a playlist of gentle music, a blanket you like, a chair that faces a patch of open sky, a cup of tea held in both hands. These small comforts let wonder last without turning into worry. Awe is not fear. Awe is the relief you feel when you fit into a large picture and do not have to carry it. When news mentions quakes near the same time as sky events, use the 3 questions again. What is it? How far is it? What changes for me? Plate edges slip because rock is rough. Quakes are local releases of stress. They do not take cues from a distant comet or a star explosion. Prepare in simple ways if you live in a quake region. Shoes by the bed, a flashlight. Drop, cover, and hold on. Then let the 2 stories sit on different shelves. Invite others into the calm. A child, a partner, a friend. Share the rule of 3 questions. Share the little ritual of looking. Share the joy of a faint tale discovered together. Teaching is a proven way to fix wisdom in your own mind. It also turns the night into a shared room instead of a private worry. Remember the gift beneath the noise. A nova tells us how thin layers ignite. A supernova shows where the heavy atoms in our bodies were made. An interstellar traveler lets us sample the chemistry of a far nursery. Together they tell one patient story. Stars live, share, and end. Clouds gather and seed new stars. Small pieces wander and bring news. Planets form and, sometimes, people rise to watch and to rest. If you are listening in the dark, take one more slow breath. Picture the traveler sliding past the sun with a pale veil and a slim tail. Picture a tiny point in a far arm of the galaxy fading after a brief flash. Picture a single shell from a deeper blast expanding like a ghostly ring. None of them ask anything of you. Your job is to notice, to learn a little, and to sleep well. In the next section, we will bring the stories together in a soft recap and set a gentle timeline for what quiet watchers might expect in the coming weeks. We will keep the language simple and the pace slow. Your curiosity will be fed. Your rest will be safe. Let us gather the threads and lay them in a simple row. A nova is a flash on the surface of a compact star that borrows gas. It brightens, then fades. A supernova is a core that fails and turns inside out, forging heavy elements and sending them into space. An interstellar traveler like 3I Atlas is a small, cold relic from a far nursery. Sunlight wakes its ices. The solar wind sculpts its tails. These three are different instruments playing in the same orchestra, not one drummer beating a single alarm. Here is a quiet timeline for the near term. Over the next few weeks, the traveler's glow may rise and fall by gentle steps as sunlight reaches new pockets. The dust tail may look broader some nights and more delicate on others. The ion tail may show a narrow thread that bends or briefly disconnects when the solar wind turns gusty. None of these changes aim it at us. They are weather, not fate. If you step outside once or twice a week with binoculars, you may notice the slow rhythm without chasing it. For the nova, expect a soft fade. On some nights it may seem the same as before. Then, almost without you noticing, it will slip a little lower. Spectra taken by larger instruments will keep pulling threads of chemistry from its light. But your takeaway can remain simple: a borrowed layer ignited, the glow is cooling, the shell is drifting. The pair will settle and, in a long time, may repeat. For the supernova, think in months. Bright remains of the blast continue to expand and thin. The early glare gives way to a more delicate scene. If you were to view it with a telescope and filters, you would see lines from heavy elements singing more clearly as the glare softens. Astronomers will follow the light curve and the changing lines to learn how much mass was thrown off and how the debris is shaped. Again, your calm idea is enough. A deep ending became a seedbed for the future. Mark a few calm milestones you can hold in your head. A clear evening each week to look for the traveler near its plotted path. A quick note in your notebook about sky conditions and what you used to look. A small check on headlines every couple of days to see if the nova has dropped another step or if new images of the supernova have been shared by observatories. Do not set alarms. Do not chase every update. Let the story come to you at a human pace. Here is a simple field guide you can read in a breath before you step outside. Face away from street lights. Give your eyes a few minutes. Use a dim red screen if you need a chart. Brace your elbows for binoculars. Look for a faint smudge where the traveler should be. If you glimpse a narrow, straight hint of tail, imagine the solar wind pushing charged gas. If you see a broader, curved wash, imagine sunlight pushing dust. If clouds hide the view, accept the gift of an early night and try again another time. Keep perspective ready in your pocket. A headline that says brighter does not mean closer. A photo with a long tail does not mean denser. A cluster of sky stories in a single week does not mean a single cause. The universe is large. Delivery times differ. News cycles compress. Your breath can stay slow. If you enjoy a gentle project, make a one-page sky sheet. Divide it into 3 boxes. In the first, write traveler and leave lines for date, sky, and a few words on brightness and tail shape. In the second, write nova and note if it is reported up, steady, or down. In the third, write supernova and jot any shared image or brief update that caught your eye. This small sheet will turn scattered stories into a quiet, tidy record. It will keep curiosity alive while protecting your sleep. Think about what these lights give back. The nova shows how thin layers ignite on a surface, a lesson for physics. The supernova shows how heavy elements are made and spread, a lesson for origins. The traveler shows how other star nurseries stock their shelves, a lesson for diversity and common ground. When you feel noise rise, return to those 3 gifts. Knowledge puts events on their proper shelves and turns buzz into music. If you want one more picture to carry to bed, try this. A harbor at night, 3 signals, a brief flare from a lantern on a small pier, a great beacon far out that brightens the horizon and then softens. A quiet skiff gliding along the breakwater with a thin line of mist trailing behind. You are on a bench with a blanket. The air smells of clean salt. The water taps the stones with a steady rhythm. Nothing asks more of you than attention and a little patience. In the next section, we will look at how people have told these stories across time and how modern instruments changed the tone from myth to measure without stealing the wonder. We will keep the language warm and the steps unhurried. We will end with a soft bedtime recap you can play in your mind whenever the night feels large. For as long as people have looked up, they have told stories to make the night gentler. Farmers watched the moon to time planting. Sailors steered by bright points across black water. Comets, novae, and the rare great starlight were once folded into myths and calendars. The sky felt close, personal, and full of signs. Those stories kept fear away and gave shape to time. They were maps of meaning drawn before we had tools to measure. Then simple glass changed everything. A small tube with 2 lenses turned faint smudges into worlds. Mountains appeared on the moon. The planets showed disks and tiny moons. Spots crossed the face of the Sunday. The sky did not shrink with those discoveries. It grew. We learned that the heavens were not perfect and still. They were places with weather and motion, not so different from the earth underfoot. A prism added another quiet step. When starlight was split, thin bright lines appeared. Different stars carried different sets of lines. It turned out those lines were the signatures of elements: hydrogen, helium, sodium. The same materials found on Earth sang in far suns. That one insight tied our world to the night with a simple cord. The sky and the ground were built from the same stuff. Photography brought patience to light. Glass plates held an image for hours while a telescope tracked a star. Faint objects that eyes could not catch slowly emerged on the plate. Nebulae turned into spirals and glowing shells. A patient worker could return night after night and build a portrait too dim for a single look. Patterns emerged. Some spirals turned out to be entire cities of stars far beyond our own. The universe was larger than anyone had guessed. Human care did the rest. Careful people counted, sorted, and compared. One mind grouped stellar spectra by their patterns. Another mind measured how the brightness of special stars rose and fell, and found a clock hidden inside, a clock that let us measure distance. Another mind mapped how those distances lined up with the way light shifted and found that space itself was stretching. None of that required mystic language. It required patient notes and a habit of checking twice. Radio ears opened a second sky. Invisible waves carried news of cold gas, of remnants of blasts, of jets from young stars, and of the gentle glow left from a time when the whole universe was hot and close. Later, eyes tuned to infrared light saw through dust to warm cocoons where stars were being born. X-ray eyes found hot halos around clusters and the scars of ancient explosions. Each band added a page to the same book. Modern detectors replaced glass plates with tiny electronic wells that count single packets of light. A short exposure now holds detail that used to take an hour. Computers stack many short views into one clear scene. Surveys sweep the whole sky night after night, marking what changed and what stayed the same. When something brightens or moves, an alert flows to watchers everywhere. Together, they decide where to point larger instruments for a closer look. That is how tonight's stories reach you so quickly. A network of wide-field cameras watches the sky like a set of calm lifeguards. One finds a new streak, another checks it the next hour. A third confirms the motion is real. Observers send in the numbers. A path appears. If the curve is open and fast, it may be a visitor from outside our family. If a point brightens in a known galaxy, it may be a supernova. If a new star appears where there was none, it may be a nova. The chain runs from the smallest backyard to the largest observatory without any one person needing to shout. New ways of listening widen the story. Instruments now hear ripples in space when heavy remnants merge. Other instruments sniff the thin rain of ghostly particles born in deep fire. When a nearby star died decades ago, a handful of those ghosts were caught underground at the same moment the star's light began its journey to us. It was a quiet bell that rang in two places, once in the heart of the blast and once in a small tank on Earth. That twin ring changed fear into understanding. The universe speaks in many voices. We are learning to hear them gently. Modern space telescopes finish the picture. Watching in calm infrared light, they pull heat patterns from dust, ice, and very far galaxies. They catch the soft glow of planets around other stars and the thin breath of their gases. They turn newborn clusters into tapestries. They show shells of old blasts as lace. The images are not loud posters, they are careful maps. They let you rest inside a larger room without feeling small. Through all of this, the tone has shifted from omen to measure without losing wonder. Myths kept people company. Measurement keeps people company too, just in a different way. It gives you simple anchors when the night seems busy. A nova is a surface flash on a dense remnant that borrowed too much. A supernova is a deep collapse that spreads the heavy elements needed for worlds like ours. An interstellar traveler is a small, cold relic, stirred awake by our Sunday. None of these are messages about your day. All of them are gifts for your mind. If you want a bedtime recap, here is one in a handful of lines. People watched, glass revealed, prisms translated, plates remembered, detectors counted, networks shared. The sky grew larger and kinder the more we listened. Tonight's lights are not a single alarm. They are a choir you can enjoy at a calm distance. Now, close your eyes and picture a dark hillside. Far below, a harbor shows three signals: a brief flare on a pier, A broad beacon that rises and softens. A small boat sliding along with a scarf of mist behind it. Above, the stars shine in their quiet. You pull a blanket around your shoulders. The air is still. Your breath is slow. The night is working on long clocks, and you can rest. You have walked a long, quiet arc with me tonight. Before we close, let us set a simple plan you can carry through the coming weeks, and then tuck the whole story into a gentle frame you can revisit anytime the night feels crowded. First, the traveler. Picture 3i Atlas as a small seed with a soft halo, moving through a wide room of sunlight. In the near term, expect modest changes, not drama. Some evenings the coma may seem a touch brighter, as new pockets of ice wake. Other evenings it may look the same as before. A narrow, straight ion tail may appear and sway like a ribbon, while a broader, curved dust tail waxes and wanes like breath on a window. These are signs of weather in space, not of any change in destination. The path stays wide, the distance stays kind. Second, the nova. Think slow fade. A borrowed layer flared, then began to cool. The light steps down by small amounts that you may not notice from night to night. Professionals will continue to read the thin, bright lines in its spectrum, but you do not need those details to keep your calm. Hold this simple truth. A dense remnant borrowed too much, cleared its throat in light, and is now resting again. Third, the supernova. Think in months and in gifts, the blast threw heavy elements outward, and the shell is expanding while it thins. As glare softens, the signatures of iron and calcium and their kin speak more clearly. Telescopes will capture lace-like filaments and knots. Your takeaway is steady. A deep ending became a seedbed. The future will grow from that dust. Now a plan for you that fits in one pocket. Choose one evening each week to step outside for 5 quiet minutes. Face away from streetlights. Give your eyes time. If you have binoculars, brace your elbows or lean against a wall. Find one bright landmark, then step to where the traveler is plotted. If you glimpse a soft smudge, pause and smile. If clouds say not tonight, do not push. Go back inside and enjoy the gift of extra rest. Set one small note on your phone that appears every 3 days. It can read simply, check sky notes. When it appears, glance at a trusted sky update. Did the nova soften a little? Has a new image of the supernova been shared? Did someone report a change in the traveler's tail shape? If yes, smile and move on. If no, smile and move on. Let news arrive at a human pace. Your curiosity deserves kindness. Keep the rule of 3 questions nearby. What is it? How far is it? What changes for me? A comet brightening is a sun-warmed breath. It is very far. It changes nothing practical in your day. A nova is a surface flash on a dense remnant. It is very far. It changes nothing practical in your day. A supernova is a deep collapse that spreads heavy elements for future worlds. It is very far. It changes nothing practical in your day. Wonder is the change. That is enough. If your mind drifts toward links between sky and ground, give it a softer link to hold. The link is scale, not cause. The sky writes on spans of years to eons. The ground writes on spans of seconds to centuries. The same night can host a bright flash in a far galaxy and a tremor under a local hill. They share a headline only because we share a timeline. Let scales sort the shelves. Here is a bedtime recap you can memorize in a handful of breaths. 1. A traveler from another star is passing by on a safe, open curve. 2. A small, dense star flashed with borrowed fuel and is fading. 3. A giant star ended, forged heavy atoms, and left a shell that will feed the future. 4. None of these lights are messages about your day. They are gifts for your mind. 5. You can watch gently or not at all, and either choice is wise. If you want to deepen the calm, make a tiny ritual. A warm drink, a favorite chair that faces a patch of sky, a short playlist that you use only for looking. When the first song starts, your breath will remember the cue and slow on its own. Use a blanket that you keep folded by the door. Let the fabric itself become a signal that the world is large and kind. Share the night with someone if you can. Teach a child how to hold binoculars steady. Show a partner how to use a dim red chart. Point out how a comet tail points away from the sun, not along the path. Let a neighbor look once and say, "I see it." That small sentence can turn a busy week into a gentler one for both of you. Carry one last picture to bed. You stand at a quiet overlook above a dark valley. Far away, a lantern flares and softens. Out beyond that, a broader glow rises and fades, like the embers of a distant hearth. Above the ridge, a tiny boat of light, glides along with a faint scarf of mist. The air is still. You are warm inside your coat. The night works on patient clocks. You do not have to keep time for it. You only have to breathe. When you wake tomorrow, the same calm facts will hold. The traveler will be a little farther along its curve. The nova will be a touch dimmer. The supernova's shell will be a little wider and a little thinner. The news cycle may be louder. Your plan will still be quiet and strong. In the final section, we will end with a soft coda. We will place a simple bow on the timeline of this wild month and close with a brief, soothing story you can replay whenever the world feels larger than your arms. No rush, clear steps, a gentle voice to walk you to the edge of sleep. Tonight we close the circle. You have walked with a traveler from another star, watched a white dwarf clear its throat in light, and stood at a safe distance while a giant star ended and gave its riches to the future. The headlines felt loud, the timing felt strange, and yet the pattern is simple when laid out with care. Separate the stories, honor the scale. Let awe be tidy. Hold this month in a handful of sentences. A small, dark seed with a soft halo is passing the sun on an open curve and will not return. A thin wind from our star sculpts its tails like a breeze through silk. Far away, a compact remnant flared because it borrowed too much gas, then began to fade. Farther still, a deep collapse turned a star inside out and sent heavy atoms into space. Meanwhile, the ground under us followed its own clock, with quiet stress and brief release, untouched by far light. You do not need more than that to rest easy. The rest is grace. The traveler gives us a sample written in light from a nursery we cannot visit. The nova lets us watch fusion on a surface. The supernova reminds us that the iron in blood and the calcium in bone were forged in heat and thrown outward to seed new worlds. The large becomes personal without becoming fearful. Make a simple promise for the weeks ahead. I will look up once in a while. I will ask 3 small questions. What is it? How far is it? What changes for me? If the answer to the last question is nothing practical, I will let my shoulders drop and enjoy the view. If clouds hide the view, I will enjoy the extra sleep and look another night. Either way, I will keep my curiosity kind. There is comfort in rhythm. Choose one evening a week to step outside for 5 minutes. Face away from bright lights. Let your eyes dark adapt. If you have binoculars, brace your elbows against your ribs. Walk the sky from one bright landmark to the next. If the traveler shows as a pale smudge, nod to it like a friend you pass on a quiet street. If the tail seems longer or straighter than before, imagine the sun's wind growing a little stronger, then gentler again. Write a single line in a notebook and come back another night. Keep a small store of calm images for nights when the mind refuses to settle. A still lake with fireflies and a lighthouse. A harbor with a brief flare on a pier, a broad beacon beyond, and a skiff that trails mist. A field before dawn with fog that thickens in hollows until tiny lights appear within. These pictures are not filler. They are bridges that carry your thoughts from noise to rest. Let us place a soft ribbon on each story. For the traveler, expect small changes and a steady exit. Its chemistry will keep speaking in quiet lines to the instruments that listen, and a few more patient observers will add dots to its path before it fades. For the nova, expect steady dimming and the slow cooling of the shell it cast off. In time, the pair may return to quiet thievery until some distant day when the lantern turns again. For the supernova, expect the glare to slacken while the lace of the remnant shows in fine filaments and knots. Let us also place a soft ribbon on the ground. If you live in a region that shakes now and then, put sturdy shoes by the bed, a flashlight within reach, and a small bag with water and contacts near the door. Practice drop, cover, and hold on once in daylight. Then set the plan aside and live your days. Prepare does not mean afraid. It means you have made room for calm. Now breathe with me once, slow and even. Picture the sun's light falling across the traveler and lifting a veil. Picture a tiny star remnant that flashed, now sighing back toward quiet. Picture a vast shell from a deeper ending, spreading so thin that it becomes part of the fabric between stars. Picture Earth turning, oceans breathing, city lights humming, your room warm and still. When morning comes, the world will be the same in the best ways. The traveler will be farther along its road. The nova will have dimmed by a small step. The supernova's shell will be wider by a small step. Your plan will still be simple. Your curiosity will still be welcome. The universe will still be generous and very far. If you need one last sentence to tuck under your pillow, let it be this. The night is large, but it is kind. You do not have to carry it. You only have to look, learn a little, and rest. Thank you for keeping me company in the dark. When you are ready, we will open the sky again and walk another quiet arc together.